Thank you for your support. Please like, subscribe, and comment if you like the content of this channel. So, one thing we have observed on this channel that if we are not asking to like, subscribe, and comment, then our viewers are not subscribing or liking the particular video. Even the content of the video is very good, still, you are just watching and you are not liking the content. So, please don't do this, and we do not want to repeat the same line again and again in same video because it takes our 20 to 30 seconds, which is wasting our time. So please like, comment, and subscribe. So let's start our today's topic, that is our ECU input as a sensor and switches. So 4 to 5 months back we have started this series on the engine control management, where we have discussed about the basic of the engine control management. So we have discussed that there are three steps in engine control management. The first one is input, then we have the second one is the processing, and the third one is the output that comes through the actuator. So in input we have the sensors and switches. In processing part we have the ECU, which is called our engine control unit or engine control management. Then we have the actuators in the form of output. So in sensors, if we talk about the engine control management, so we have the engine speed sensor, water temperature sensor, accelerator pedal sensors. In switches we have the AC switch, ignition switch, and so on. So these sensors work as a input, and computer, which is nothing but our ECU, which works as a processing unit, and then actuators, which gives as a output. So what is the role of ECU is to determine the fuel injection volume, fuel injection timing, intake air volume based on the various input from the sensors and the switches. This is the first role of ECU. Then second, what it does, it process the input based on the sensors and switches. Then it will give the output to the actuators. It will control or command that fuel injection volume, then fuel injection timing, then other controls like intake restriction, EGR, glow plug control. So all these things are done in the engine control module. So all these steps are performed in the engine control management. So today we will discuss only about the sensors as a input, and then we will go to the computer, that how it process, and then we will go to the actuator. So we are running this particular series. If you are liking the content of this series, please like. So let's start with the sensors. So before going to the sensors, so first you need to understand there are two types of engines. So first is the plunger pump type, and the second one is the common rail. So in plunger pump type, the major difference is that SPV, this unit spill control valve and throttle control motor will be like this. But when it comes to the common rail, you will be having the injectors. So suppose if you are using the four cylinder engine, then you will be having the four injectors: injector 1, injector 2, injector 3, and injector 4. So there is a difference between plunger pump type engine and the common rail type of engine. Then today we will not discuss about the actuators. Today we are going to discuss about the sensors. So you can see one time, these are the sensors. These are the different sensors which are used in the engine. So like crank position sensor, engine speed sensor, intake air pressure sensor, intake air temperature sensor, and so on. So based on these sensor as a input, your ECU will process the input, and then it will send to the actuators. You will be having these as a by default in every ECU, that battery and battery positive, that is main relay. So the supply for the ECU will always be there for each and every ECU, irrespective of whether it is engine control ECU or whether it is a BCM, that is body control module. So these are the different topics which we are going to cover under this series. So first one is the mode sensor and switches. We will try to understand in this topic that how the ECM understand the sensors or mode of the sensors and the switches, how the ECU takes the value from the sensor and switches and it process, how it understand. This is the thing we will try to understand in first one. Then we will be having the temperature sensor, position sensor, airflow sensor, pressure sensor, speed sensors, air fuel sensors, NOx sensors. So we will try to understand all these sensors in detail. So before going to the sensors, so let's understand the packaging of these sensors. So you can see that mass airflow sensors is packaged here, then throttle position sensor is positioned here, then intake air temperature sensor, then MAF, then oil pressure sensors, then you have the camshaft position sensor, then you have NOx sensors, and you can see there are many other sensor, accelerator position sensors. So this is the structure or the position of the different sensors, where they are placed and what is their function. We will discuss all these sensors in detail one by one, but as of now you just understand that where they are placed and what is their position in the engine. So let's see here also it is showing the position of the different sensors, camshaft sensor or crankshaft position sensor, NOx sensors. And then let's move to our today's topic, that is our mode sensor and switches. So this is the first topic which we are going to cover. So in this particular topic we try to understand that how ECM takes the sensor and switches input. So what is the important for ECM to know the position of the or the mode of the components. So what does it mean? So a switch is used as a sensor to indicate the position or the mode. Switch may be used as a supply side or the ground side of the circuit. So there are two ways by which the ECM can take your signal. First is the supply side, which is nothing but the power side, and the second one is the ground side, where so there are two ways by which the ECM can understand the switch condition or the component condition. So first is the supply side circuit and other one is the ground side circuit. So supply side circuit is nothing but if the supply is going to the particular ECM pin, then it is called supply side circuit. So power side switch circuit is a switch located between the power supply and the load. Sometime power side switch called as a hot side switch because it is located on the hot side, or you can say it is located on the battery side before the load in the circuit. So we will try to understand by one example. This is your ECM and is having this resistor. Then this is your battery, that is our power supply. Then this is our switch, right? So what does it power side switch circuit, what does it mean? That a switch is located between power supply and the load. So this is your load and this is your power supply and the switch is located here. So just let me erase this and we will try to understand one more time. So on power side switch with the switch open, so there might be two conditions. So first is the switch open. So switch is open, then there is a no voltage at ECM. So what would be the voltage at this point? If you measure this voltage, that would be 0 volt. The second condition what will be there is when switch is closed. If switch is closed, then the battery positive, whatever voltage is applied on this particular terminal, it will be reflected on this point also if your switch is closed. So when switch is closed, then voltage is present at BCM. So what does it mean? So whenever switch is closed, if voltage is coming on the ECM, then it is called as power side switch circuit. So whenever switch is closed and ECM is getting the battery voltage or voltage which is applied on this terminal, then we call it power side switch circuit. We will try to understand by one particular example. Suppose stop lamp switch. When brake pedal is depressed, then stop lamp switch closes and sending the battery voltage to ECM. This signals the ECM that vehicle is stopped. So let's try to understand one example of stop lamp switch in the detail for the power side switch circuit. So this is one of the circuit for stop lamp switch. This is just a sample circuit. So this is our B positive. B positive is nothing but the battery voltage. Here we have put. Then this is our fuse. Then this is your stop lamp switch and this is your stop lamp, and this is how it is connected to the ECM. So there might be two conditions. First is when switch is open. Okay, when switch is open. So when switch is open, then here till this point it would be B positive, but after that it would be a 0 volt, right? It would be a 0 volt. Then when switch is closed, then what will be happening? That STP or brake voltage, the STP and or brake signal voltage would be B positive. I hope you understand this concept. When STP or brake voltage would be positive in case of switch is closed, then we call it power side switch circuit. And once it will be closed, your stop lamp will be turned on. So there are two types of switch. Normally open and normally closed. So this particular switch, stop lamp switch, is the normally open switch. What does it mean? So suppose till the time this particular switch or plunger will not be pressed, then it will remain open. So you can see here, this is the kind of switch and this is the plunger of that switch. So once this plunger will, you know, will be pressed, then it will be closed. So here you can see this in this arrangement, that this is the pedal, and once this pedal is pressed, then the force will go on this plunger and plunger will close this particular switch. Once this particular switch will close, then your current will start flowing into this, and your STP or brake signal voltage will become B positive. Be positive. If you are working in passenger car, then it will be a 12 volt. If you are working in the commercial vehicle where you are using two batteries, then it would be a 24 volt. So I hope you understand that what is the power side circuit switch and how it works. And when we say this is a power side switch circuit, so whenever the switch is closed and your ECM is getting the positive supply on the pin, then we call it power side switch circuit. Suppose sometimes if you are getting a issue like your stop lamp is continuously on without pressing this brake pedal, so what does it mean? That your switch is continuously pressed. So there is a chance that this particular stop lamp switch might be having some issue, or this particular arrangement is, continuously pressed. That's why your stop lamp is on. So apart from stop lamp, there are some more example like ignition switch, park and neutral switch, then transfer low position detection switch. So all these are the examples of power side switch circuit. So I hope you understand the power side switch circuit. Now we will move to the ground side switch circuit. So before moving to the ground side switch circuit, just we will see that how you can measure the voltage through the digital volt ohm meter. So DVOM will measure the 0 volt with the switch open. So suppose if your switch is open, then at ECM pin, if you are measuring the voltage, then it will come as 0 volt. As I told you earlier as well, when switch is on or closed, you can say, when switch is closed, then what will happen? This particular B positive voltage will go here. So suppose if it is a 12 volt battery, then it will show 12 volt. If it is a 24 volt battery, then it will show the 24 volt here, and it is called as a power side switch circuit. So this is how you can measure the voltage through the DVOM, digital volt ohm meter. If you have any question in this, you please comment in the comment box. I will try to give you the answer. So let's see the second one, that is the ground side switch circuit. A ground side switch circuit is located between the load and the ground in a circuit. So what is the difference between power side switch circuit and the ground side switch circuit? So you can see earlier when the switch was here, we were using the B positive on the switch here, but now the case is totally different, that on switch side we are using the ground. So let me just erase it. You have the ECM, then the supply voltage, then this is your resistance, and then this is the switch arrangement, and it is connected to the ground. So here also we will take the two cases. One is the when switch is open and when switch is the closed. So inside the ECU there is a resistor load connected, which is we have already said, connected in the series to the switch. ECM measures the available voltage between the resistor and switch. When the switch is open, ECM reads the supply voltage. When switch is closed, the voltage is nearly zero. So we will try to understand. So this is ECM and here you have one supply voltage. So suppose supply voltage is 5 volt or 12 volt. When this 12 volt is coming here and we are talking about the position is switch is open. When switch is open, then at this point that voltage would be B positive, or you can say the supply voltage, whether it is 5 volt or the 12 volt, right? At this point, what would be the voltage? 0 volt, because there is no power supply, nothing, right? When the switch is closed, so suppose your switch is closed here, then what would be the voltage here? It would be the zero voltage, nearly zero voltage or zero voltage. Then this particular voltage is zero voltage, so here also it will come the zero voltage, but at this point it would be the supply voltage. That's the thing you have to just remember. So this is how your ECM reads the power side switch circuit or the ground side switch circuit, and I hope you understand what is the difference between and how the ECM reads these values. So some of the example of this, like TPS idle contact switch, power steering pressure switch, overdrive switch. Let's see the how the DVOM will, that is digital volt ohm meter. So first is like when the switch is open, then DVOM will read the supply voltage at this particular pin when switch is open, because there won't be any current flow in this and the same supply voltage will come on this point. But when switch is closed, then DVOM will read the zero voltage, nearly zero voltage on this point, because your all current will go to the ground. So this is how the ground side switch circuit is designed. Then neutral start switch is given to make sure that your vehicle is in neutral. Then you have the starter and then STA, which is going to the ECM. So when ignition switch is turned on, so suppose when it is turned on, then battery voltage will be applied on the STA. So whatever voltage will be on battery, then suppose 12 volt, then it will, STA will also be having the 12 volt in case of switch is closed. When switch is not closed, it is open, then it would be a 0 volt. I hope you understand that how the ground side switch circuit and this switch circuit works. But can you comment in the comment box that what type of arrangement this one is? Whether it is a power side switch circuit or the ground side switch circuit when we are talking this. Let's see some more example. So this is one of the arrangement, the electric load signal, that ELS. ELS is this particular signal, circuit signal, that ECM when significant electrical load has been placed on the charging system, such as when defogger or tail lamp circuit. So this is the tail lamp relay and this is your defogger. So when switch is open, then ELS would be 0. ELS would be 0. When switch is closed, then ELS would be the your battery voltage. I hope you understand this one. Similarly, for the air conditioning signal, then overdrive circuit, you can see here the OD circuit is a ground side switch circuit. And why it is ground side switch circuit? If you see the arrangement of this overdrive circuit, so if you see the example, when the switch is open, then here you will get the B positive. But when switch is closed, then you will get the 0 volt here. So I hope you understand all these examples. If still you have some confusion, then you please let me know in the comment box. I will explain you again. There are two types of signal for the ECM. One is power side and other one is the ground side. In power side, when switch is on, then it will get the B positive. When switch is on for the ground side, then ECM will get the 0 voltage. This is the difference. Please comment in the comment box if you have any confusion. Thank you for your time.